How you doing? I'm your man, John Wilson. Welcome to Unit 4, Lesson 9.1. Today we're going to understand how to transform a figure through a translation graphically. Then you're going to learn the rules and procedures to translate the same figure algebraically. Now, very important, I want to draw your attention to this. These are the 5 sets of changes that happen to every transformation that we're going to be dealing with in this module. We're going to be dealing with a reflection, a rotation, a transformation, and 2 types of dilations, an enlargement and a reduction. You're going to see this strip on every single set of notes you get from me and every single intro slide because it is that important. Notice that when we transform a figure, a lot of things change. The size changes. The orientation can change. The position of the figure can change. You know what orientation is? What's orientation?
The way someone's presenting.
Yeah, you could say, like, say this would be a rectangle, right? So orientation means that we maybe turn it, something like that. We do a rotation. So where here it was laying on its side, now it's kind of standing up. That's orientation. Obviously, position is just the position, and then the size, I mean, it can get bigger or smaller. What's the only thing up here that you never see change?
The shape.
The shape never changes. If it's a rectangle when we start, it'll be a rectangle when we end. If it's an isosceles triangle when we start, it will be an isosceles triangle when we end. If you start with a perfect square and you end up with a parallelogram or a trapezoid, you did something wrong, boo-boo, because the shape itself will never change. If you start with a square and end up with a circle, I don't know how to fix that. You might want to go back and see what you did wrong. So shape is the only thing that does not change. That's actually an error in your book that I caught. In the book it says that the size, shape, and the orientation can change, but that's an error. So position, orientation, and size can change, but never the shape itself. All right, so just what is a transformation? Like I said, a transformation is a change in the position, size, or orientation of a figure. This is where you're writing. You're writing all this down. Vocab is the most important thing to start off a new unit because you need to know how to communicate with me when in this module I say what's your preimage, what's your image, where are your primes, where's your double primes, triple primes. I expect you to know this vocab as we go through it. If you don't know the vocab in the beginning, you're going to struggle because all the quizzes and tests are worded just like that throughout the rest of your mathematical career. First, in order to do a transformation, we need a figure. In order to have a figure, we must plot the figure's vertices. That is simply where 2 lines intersect to form a point. Our figure has 3 vertices. 1, 2, 3. Point A, point B, and point C. And I'll give you a second to write all those in, because I know it's a lot of stuff to write in. You're always going to start by being asked to put a figure on the graph. Sometimes you'll have the figure, usually you got to put it there yourself. Yes, Sydney.
Are there going to be transformations that are going to change the shape of it?
No, the shape will always be the same. There's no transformation that we do at this grade level that changes it. We'll change the size of it, it'll get larger or smaller, we'll change the orientation of the figure, we'll change the position for sure. We will never change the actual shape. So like I said, if it's a square, it ends a square. Maybe bigger, maybe smaller, still a square. Alright, so the first things first, we need to plot this. So, in case you forgot how to plot points, we start at the origin, we're going to plot point A. So to get from the origin to point A, we always go left to right first. What am I doing, left to right?
Left.
How many spots?
6.
6. 1, 2, 3, 4, 5, 6. Then up or down? Up. How many spots? 4. 1, 2, 3, 4. And you put your first point. Make sure you label it. That is point A. Make sure you're doing this on your paper, so that way you can stay current with us because you're going to need all these figures and all this information. Once you have point A, you go and you do point B. Speed it up a little bit here. 1, 2, 3, 4 to the left, up 2. That is negative 4, 2. That's point B. Last but not least, we need point C. Negative 1 on the X, 1, 2, 3, 4 on the Y. Once I have all my points plotted, I then go in and very simply connect the points with lines. Yes, it is a triangle. It has 3 vertices, therefore 3 points. It's a triangle. So we connect this all with lines. Write one here. And that's going to be our little triangle, our little figure, A, B, C. So now that we have our figure, we have to learn some more vocab. This figure that we plotted here, our original figure, is known as the pre-image. Anybody have an idea why it's called the pre-image? Anyone have a thought on that? Kens and Eric?
It's before?
It's before what?
I don't know.
Well, what are we doing to these figures? What are we going to be doing?
Transforming.
We're going to be transforming. So it's the pre-image. It means before we transform it. Yes, we graphed it, but before we transform it, it's known as the pre-image. That means that once I transform it, what do you think it's going to be called?
The image.
The image. So we start with the pre-image, we end with the image. We have A, B, C. Everyone have all this down?
Yes.
All right. So now we want to go and we actually want to do our first transformation. Our first transformation is known as a translation. When I say translation, I don't mean that we're translating English to Japanese or Japanese to German. We are going to be translating this figure, triangle ABC. Now, translation is just a fancy way of saying that we're going to slide this figure. We can slide it left, up, down, right, anywhere we want on this graph. We're going to slide it around. Now, in order to slide it, we need directions. Generally, directions will be given to you. You're not going to be asked just to randomly create directions. For this particular figure, we want to translate it 6 units down and 4 units to the right. So that means that we're going to be taking each point, point A, point B, and point C. We're going to move each point 6 units down, 4 units right. That is known as mapping points. When you move a point, when you transform a figure, you are mapping those points from the pre-image to the image. And we'll go through point A, point B, point C. Now, when we translate a point, or when we transform a figure, all the points in the image are going to have a little notation on them. And I'm going to show you what this looks like as we transform the first point. So, we're going to go to point A. We are translating it 6 down, 4 right. So we start at A, we go down 6. 1, 2, 3, 4, 5, 6. 4 to the right. 1, 2, 3, 4. And that is going to be, once again, A. But there's going to be a little something different here now. There's going to be a little notation next to it, right there, a little dash. A little dash. And that little dash is known as the prime. So this is no longer point A. This is point A prime. If we were to translate the figure again, we'd use 2 dashes. It would be a double prime. We transformed it a 3rd time. There would be 3 dashes. It would be a triple prime. We are just transforming this figure 1 time. So it's going to be A prime, and it looks just like this, A prime. When we transform B, it's no longer going to be B, it's going to be B what?
Prime.
B prime. When we transform C, it's not going to be C, it's going to be C prime. Now, I'm not asking you to do this right now, so don't write this. But should I ask you to transform the figure again and again and again, you would just add primes to it. Double prime, triple prime, so on and so forth for each new figure. For right now, though, we're just doing one simple translation. So let's repeat the process. We're going to go to point B now. Same thing. What am I moving it? How am I moving it?
6 down, 4 right.
6 down, 4 right. So 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4 right. And what's that point going to be called again?
B prime.
B prime. Don't forget the little dash. If you forget your primes, when you're mapping, it's going to be wrong. Everything you do is wrong. This is no longer point A. It's A prime. That's not B. That's B prime. We go to C now. Down 1, 2, 3, 4, 5, 6. Right 4. 1, 2, 3, 4. And that is going to be C prime. Yes, Sydney?
Can there... Actually, never mind.
I'm sorry?
Never mind.
Right? All right. And once we translated all the points, we simply go back and reconnect them with lines. And we should note the following. In a translation, only the position of the figure will ever change. We will never change the orientation. We will never change the size. So looking here, I had a triangle when I started. It was orientated this specific way, and all I did was change its position. It's very simple stuff. You just need to be careful because if you miss any one of these points, everything you do is wrong. If you translate A, B, or C wrong, you don't notate the primes, the whole process is wrong, and you've got to start over. That's also why I say for generally in math, you never use pen, but especially when we're working with graphs because you don't have the ability to erase. What's up? Well, the directions I made up for this particular demonstration. Depending on the figure you're being asked to transform, the directions could be different. You could be asked to go up or down or left or right. For this particular demo, I wanted to see what would happen if I moved this figure 6 down, 4 right. They're just numbers I chose at random. Okay. You will have clear and specific directions when transforming what ways I want you to go. Okay. Let's try a couple examples here. So we have 2 figures. We have a triangle, and then anybody know what that is on the right? What is that? Remember, a parallelogram has what? No, a parallelogram has 2 sets of parallel lines, right? So a parallelogram would be what? Something like this. Parallel, and then a little more parallel. You get the idea? Parallel. That's a parallelogram. That is a trapezoid. You have 1 set. You get the idea. Hey, my drawing is horrible. That's not really parallel. We want to translate this. So I need directions. First one, I'm just going to translate it 4 units down. So we're going to move from SRT to SRT. How do I get these numbers? Like I said to Marissa a second ago, I'm creating the directions. The only reason they're invisible is because usually when I put them on the papers, I would have people working ahead trying to go ahead and translate it. I don't like that because sometimes they make mistakes and they're not paying attention, right? So the reason I hit them is so that we work together. Man, it comes with directions. Yeah, it'll come. You'll have it, don't worry. So we want to translate this 4 units down. So we go, doesn't matter where I start. Where do you guys want to start? SRT. S, so we start with S. What are we doing?
4 down.
4 down. 1, 2, 3, 4 units down. That is going to be S prime. We go to R, down 4 units. 1, 2, 3, 4. That's going to be R prime. And then T, 1, 2, 3, 4. And that's going to be T prime. You go in, it's a big prime. You go in and you connect all of the points with lines, and you have officially translated SRT over to SRT prime. The only additional step I'm going to ask you to do now is write the coordinates down. So you need to know the coordinates of your new figure. I need the coordinates of S prime, R prime, and T prime. So let's go to, let's go to Anthony. Anthony, give me the coordinates for S prime. What do you think they are?
-1, -4.
-1, -4. Let's see. Oh, S prime. -1, 1, 2, 3, -3. Close!
Oh.
Close, but off by just 1, and unfortunately everything
I'm
you've done
sorry.
up to that point would have been wrong, so you gotta be careful. Alright, let's go to Nicole Manat.
Oh.
Yes.
You got R prime or T prime? Which one do you want?
R.
R prime, alright, what you got for R prime?
Okay, 3, 0.
3, 0. 3, 0. Good job.
Okay.
Good job. 3, 0. Be careful. Make sure you know how to read these points. You can do all the easy stuff correctly. If you can't label the points, then unfortunately, it'll be wrong. Yoo-hoo! Yoo-hoo! T prime, what you got, dude?
3,
Let's read it carefully. You start at the origin. Start at the origin. To get from the origin to T prime, we're going right twice, so that's 2.
Oh, 2.
And then are we going up or down?
Down.
So 1, 2, 3, 4, 5, 6. Because we went down, is that positive or negative?
Negative.
Let's see if you got the right one. Ooh, 2, -6. There we go. All right. So we officially translated SRT to SRT prime. We're now going to move over to, which is apparently a parallelogram here, trapezoid, W, X, Y, Z. What point do you guys want to start with?
W.
W. Notice that this time, we're not just moving in one direction, we're going 2 down, 2 left. 2 down and 2 left, so we'll start with W, and we go down 2. 1, 2, left 2, 1, 2. This is no longer W, it's W
Prime.
prime. I know I'm gonna get annoying because I'm gonna keep saying that to make sure you don't forget it. Somebody always does. That's W prime, we go to Z, down 2, left 2. Drop a point, that is Z prime. Make sure you're doing the same thing I am. Go to X, down 2, 1, 2, left 2, 1, 2, and that is going to be X prime. One last point to go. We go to Y. We're going down 2, 1, 2. We're going left 2. and that is gonna be y prime. We then go in, we reconnect all of the points with lines, and we should have same figure, just in a different location. Boom, boom.
Mine looks weird.
If yours looks weird, maybe you missed a point. Go check, make sure.
No, it looks the same, but it just looks weird.
Well, let's see what you got here.
No.
Good, 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 good. The only reason it looks a little weird is because I have straight lines. Your lines are a little curvy there.
Yeah.
And for y, you went down 2, left 1. Gotta be careful. And that's why you don't use a pen. Gotta use a pencil. Alright. Sydney, pick a letter. Which one do you want to do? W, X, Y, Z. Give me a letter.
Y.
Y, what's the coordinates for y prime?
-7, 3.
Survey says, ding, ding, ding. Sydney's got it right. Alright, good job. Yeezy, first easy. Pick a letter. What do you got?
W.
W, okay, what's W prime?
2, 2.
2,
2.
2. Would help if it works. 2, 2, good job. Alright. Benjamin, pick a letter. What do you got?
X.
X. X marks a spot. What's your spot?
Oh.
-7,
-7, -8. Let's see. Oh, close.
Excuse me.
-7, -7. Let's check to make sure I'm right. 1, 2, 3, 4, 5, 6. -7. Down. 1, 2, 3, 4, 5, 6, 7. Just gotta be careful. All right. If you missed it by 1, go back, check what you did, fix your work. Mistakes are all part of the learning process. Mr. Gray Hambone.
Oh, thank God.
You got 1 letter left, man. Z prime. What you got? Now remember, we're looking at Z prime. So we're going from the origin
Oh yeah, yeah.
to Z prime. 2's good, comma.
-6.
Let's see. Good, 2 comma, -6. All right, good job, good job. It is. As long as you're with it,
This is
You'll
the
get it.
first time I like shapes. I never like shapes. Me too.
told you, the geometry portion is easy. I'm okay with the algebra stuff, really, really good with the geometry stuff. Plus it's easy, you're moving, you're going up, down, left, right, slide. All right, 4, 3, 2, 1 on this. All right, so now that we know how to translate figures graphically, we're gonna go in and we're gonna figure out how to do it algebraically. Now, when we do it algebraically, we have a very simple set of rules. This is why when you guys were doing your whiteboard problem, I was able to do it so quickly in my head, because I know the rules. Depending on whether or not we're going right, left, up, or down, there's a very specific thing that happens to each coordinate. If we go right, we are adding to the x-coordinate. If we go left, we're subtracting from the x. That makes sense, right? Because if you think about the origin, if we're going left, that's negative. If we go right, that's positive. If we go up, we're adding to the y. If we go down, we're subtracting from the y. That also makes sense because if you start at the origin, if you go up, that's, and if you go down, it's negative. So that makes sense. Yes, Sydney?
Why if we go right, -2 units?
You can't go right, -2 units.
Okay.
Yeah. Just like you can't go left, +4 units. Right?
Oh,
Okay. So let's see what this looks like. So let's just say I'm going to pick a number out of thin air here. If I go right 3 units, that means I'm adding 3 to the x-coordinate. So what's going to happen here? What's the rule going to look like? It's going to look like this. This is known as coordinate notation. It's always going to be x comma y, then an arrow, and then you notate what is happening to the specific coordinate. Since I went right 3 spots, that means I'm adding 3 to the x. Does the y change?
No.
No. I'm only moving right 3. The y does not change in that circumstance. What if I were to go left? Give me a number, 1D. Any number, I don't care.
10, 7.
10. 10, 7. So if we go left 7 units, that means that we are subtracting 7 from the x-coordinate. So the coordinate notation would look like this. X comma y, arrow. We're subtracting. So it would be x minus
7.
7.
Or 10.
Does anything happen to the y?
No.
No,
The
it
y
does
stays
not
the same.
change. Yes, Sydney, do you have a relevant question?
Yes. just like right 3 and left like 7 like that's all?
I mean, you could go, I could ask you to go right 3 up to left 7. Generally speaking though, on any test or quizzes, at most, you'll only be asked to either go right or left or up or down. Like 2 of them. You know, up and right, up and left, down and right, down and left, something like that. You won't be asked to like, you know, go right 4, up 4, left 4, down 4, because then you don't know where you started, right? Alright, so if we go up, give me a number, Laura, give me a number.
2.
2, should think about that. So we want to go up 2 units, which means we're going to add 2 to the y coordinate. So the coordinate notation looks like this, x comma y. Make sure you're paying attention to how to do this because you're going to have to write rules on the next section. X comma y plus 2. Pretty simple, as long as you just follow the rules in your notes. Last but not least, Allison, give me a number.
8.
8. So we're going down 8 units. If I go down 8 units, that means I'm subtracting 8 from the y coordinate. My notation is going to look like this. X comma y, arrow. X does not change, but what's happening to the y? We're subtracting 8. Mr. Guerra. Now we're going to work with coordinate pairs, bud. And I'm going to pick the number for you, just to make sure that you're completely 100% with this. So we look at the first one here, 3 comma 5. And I want to go right 26 units. So what am I doing to the x coordinate?
Adding.
No, I'm just him. What am I doing? It's his question.
Right.
I'm going right 26 units. So what does that mean? What am I doing to the x coordinate? No, it's his question. Let him answer. Yeah, but what am I doing to it? We just went over it. Come on, bud. What do we got? I'm adding what? To the x coordinate. So I'm going to add 26 to the x coordinate. And here's what it's going to look like when you write it out. It's going to look like this. You write the coordinate pair 3. What are we doing to it? Adding or subtracting? Adding. So 3 plus 26, comma, the y coordinate is 5. You with me on why we wrote that? Yes? Yes?
Yes.
3 plus 26, that's the coordinate pair. The original coordinate is 3 over here, comma 5. We're adding 26 to the x. The y does not change. That is going to equal my new coordinate pair. What's the x going to be, guys? 26 plus 3 is 29, comma 5. That would be my new coordinate pair. So if I take 3 comma 5 and I translate it 26 units to the right, I would end up at 29 comma 5. Matthew Crop. We want to move left. How old are you? We want to move left 13 units. Okay. So when I move left 13 units, what am I doing to the x coordinate?
You're subtracting 13.
I'm subtracting 13 from the x coordinate. So you tell me, using this as a guide, what would that look like? What's the x coordinate?
So 2
2.
minus 13,
Uh-huh.
comma 1,
Comma 1, and that gives me the new coordinate pair, which is? Just him, please.
equals, 11,
Positive or negative?
negative,
Negative 11, comma?
comma 1.
1. Good, because the y did not change. Thank you. Thank you. Thank you. There you go. All right, let's go to Caitlin. Caitlin, what's the square root of 49?
7.
7. Okay, so what we're going to do is we're going to go up 7 units. Up 7 units. When I go up 7 units, what am I doing?
You're adding
Adding what?
the y.
Adding how much to the y?
7.
7. So we're going up 7. So we add 7 to the y coordinate. Using these as a guide, what's that going to look like? Does the x change this time?
No.
No. So we'll just write the x coordinate, negative 3, comma, negative 2. And then what am I doing to the negative 2?
You're adding it?
I'm adding how much?
7.
7. So I add 7 to it. Boom, boom. That's going to equal, what's my new coordinate pair going to be, Caitlin? Just her, please.
5.
Hold on, let's look at the x. Did the x change? We're doing the x first. Did the x change?
Negative 3, comma 5.
Perfect. Negative 3, comma 5. Good job. Thank you very much. Sebastian! Let's go up. Square root of 169. Don't use that. Come on. Go through your perfect squares, man. What you got?
12.
12 is 12. 12 times 12 is 144. Think higher.
14.
14 is too high. It's 196. A little lower. 13. There we go. Third time's a charm. So we're going down 13 units. When I go down 13 units, what am I doing to the y? Subtracting 13 from the y. And then just Sebastian, tell me, what is that going to look like in notation?
13.
Negative 13, comma.
Negative 13 minus 13.
Negative 13 minus 13. That's going to give me a new coordinate. What's it going to be?
Negative 13.
Uh-huh.
Comma negative 20. Positive 26.
Comma negative 26. Remember, we are not multiplying or dividing those two negatives.
Is that a
We're
7?
subtracting. Same sign, adding, keep. So we add them together, 26. Keep the sign negative. It is a negative 26. This is a 13, sorry. Trying to write small here. It's negative 13, comma. Negative 13 minus 13. That equals negative 13 minus 26. Any questions on this? Any questions? Let's try a couple more here, just to make sure we're on the right track. All right. We're not going to do all of these. I'm just showing you what the different possibilities are that can look like on a quiz or a test. You'll be given coordinate pairs, specifically figures, A, B, C. What kind of figure is that going to be? 3 points.
Triangle.
Triangle. So we're given the same triangle 4 different times. We're being asked to translate it 4 different ways. We'll do 4 of these just to see if we can get the right coordinate pairs. Let's go to Marissa. All right, Marissa. First one, we're going to go to the B coordinate. What are you doing to the B coordinate? What are you being asked to do when you translate it? What's the directions?
Go right 3 up 4.
Okay, so right 3 up 4. So if I'm going right 3 up 4, what's happening to the x coordinate if I'm going right 3?
You're gonna add 3.
I'm going to add 3, okay. And what is happening to the y?
The y, you're gonna add 4.
You're going to add 4 to it. See how this is a whole lot easier, guys, than trying to sit there and do 1 point, 1 point, 1 point?
Yeah.
But you got to know both. This is a way to check your work just in case you make a mistake, because you're still going to be working with graphs. So, having that information now, knowing the rules, what's my new coordinate pair going to be, Marissa?
1, 9. 1, 9.
1, comma, 9. And am I just going to write B?
B. No.
What do I have to write? Am I just going to leave it as B?
No, B prime.
B prime. There we go. B prime. All right, all right. Next one. Cantonary. Here's my directions. Note the directions change. Pick a letter. What do you want to work with? A, B, C. Everyone always picks A, all the positives. All right. So this is coordinate notation now, which is easier to read than the standard form directions, because they're telling you specifically what happens to the x, specifically what happens to the y. So what's happening to the x coordinate here? We're adding 4. And what's happening to the y coordinate?
Minus 3.
Subtracting 3. Okay. What's the new coordinate pair going to be?
7.
Comma.
1.
7, comma 1. And I'm just going to leave that as A, right?
No, A prime.
A prime. If I left that as A, would that be right or wrong?
Wrong.
Wrong. 100% of the time, 90% of the time. Alright. Whoops. That doesn't make any sense. 11? I'm going through cards now. Allison! Alright. Well, that time I was, remember before I was picking a random, now I'm actually going back to the cards. So, I mean, sometimes you get called twice, sometimes you don't get called at all. Yes.
Wait, are we only gonna do one part of it?
Yeah, we're just doing each one because,
Okay, where?
well,
You said A, I thought you did this one.
because having gone through this now 4 times, I realized that by now most people know how to do this, so it was taking way too long to go through this when we have one more small section to do. And if you don't understand it, you feel like we need one more example, I'll go back and do another one. But I'm pretty sure it's clicking for you guys right now. Allison, we're looking at this one, A, B, C. We haven't done the C coordinate yet, so let's try to work with that one. All right, so we have directions, x minus 2, y plus 7. So that means that we are subtracting 2 from the y. We are adding 7 to the x. And then what are the coordinates going to be of my C prime?
-8, comma, -1.
-8, comma, -1. You got that pretty quick for all that. Oh, why did I get that one? Oh, no. -8, comma, -1. That is a -1. Just looks a little...
You sound like an option.
I'm trying to sound like one of those infomercial guys. Hi, I'm Johnny! Today we're working with coordinate notation. You thought you had everything in your home, everything you needed, but everything is not complete unless you have coordinate notation in your life today. If you call now, you can get it stretched out 3 flex play options. We will get it to your door tomorrow. Maybe today. I might drive it there myself. Maybe that's what I should have done. Anyway, one last one. Let's go to Cardona. Is he here? Abby.
Why aren't you here, Cardona?
Abby. Medina. I'll be nice. I'll let you pick A, B, C.
A.
A. All right. So what's happening to the A?
You're subtracting 9.
Subtracting 9. What's happening to the 4?
Subtracting 1.
Subtracting 1. And my new coordinate pair for A prime is going to be
6, 3.
3 minus 9.
Oh, negative.
Negative 6, comma, 4 minus 1 is? 4 minus 1.
Oh, 3. Sorry.
4 minus 1 is 3.
Oh my
Yeah, she
God.
just got nervous. It's okay. It happens to everybody.
Yay!
All right, good. Questions on this at all?
No.
All right, quick whiteboard. This should take maybe 30 seconds. 4 3 before we go.
You're good.
You're good.
Oh, he wants to go to the back.
Well, sorry, last 10 minutes of class. There's 6 minutes left. You gonna be your talk? If it's an emergency, you can go, but unfortunately, it's the last 6 minutes. You know the rules here. So don't get mad at me for the rules. You have to go when you finish the whiteboard, but last 10 minutes you can't go. So, it's not like it's a surprise. The rules have been there since day 1. Last thing, going in this order, starting here, working all the way around the world. Last thing you just need to write the rule. That means we're going to figure out what happened to get us from the first image to the second one, or from the pre-image to the image. How can you tell the difference between the pre-image and the image? What sticks out at you, real quick?
Color.
Well, the color, but take away the color. Something else.
They moved, like the positions moved.
Yes, but there's some little teeny tiny things in the gram.
The prime. Wait,
Prime notation. Do we see primes here?
Oh.
No, when I see primes here. That's how you can tell the difference between the pre-image and the image. The image will have the prime notation, whether it's prime, double prime, triple prime. So we want to examine how many units did X move and Y move. That's where you look at your rules. But all that you know how to do. So what's different here? Here's what's different. In order to find the rule, 2 things have to be done. First thing, you have to pick a set of corresponding points. Corresponding points are very easy to recognize. If we look at K, there's only one point in the image that corresponds to K, and that is K prime. K prime. So what point do you think corresponds to Z? Z prime. What point corresponds to I? I prime. Those are corresponding points. Same letters. One of them's prime, one of them's not. One of them's in the pre-image, one of them's in the image. So we pick any set of corresponding points, such as K and K prime, Z and Z prime, I and I prime. Pick any set. What you cannot do is you cannot go from K to I prime. You cannot go from Z to K prime. Has to be corresponding points. I'll let you guys write that in. When you're done, put your eyes up here. There's only like 6 minutes left in class. Yeah, plenty of time because this is easy stuff. If you can count. 1, 2, 4, 7, 9, 12. Okay, so for this particular demo, we're going to work with K and K prime. Easy way to screw this up is when you're trying to write the rule, you're trying to move from the pre-image, let me make this red. You're trying to move from the pre-image to the image. You'd be surprised, despite the fact this is easy on your whiteboard, some of you will probably make this simple error, but that's okay because we'll fix it. We're always moving from the pre-image to the image, from the standard coordinate to the prime coordinate. If you do it backwards, your rule is going to be backwards. So we pick a set of corresponding points, K and K prime, and all you have to do is identify how you get from here to here. Do I have to go up, down, right, or left? We always want to go right or left first. So Cedric, to get from here, from K to K prime, you have to go right or left?
Left, right.
Right. How many spots?
2.
2. So I have to go right 2,
Up, down 1.
and then down 1. Once you identify how to get from the pre-image to the image using corresponding points, then you look at your rules and you say, okay, if I went right, what am I doing? Was I adding and subtracting to which coordinate? What am I doing if I go right? I'm adding to the x, so it's going to be x plus 2. We went right 2. And then Cedric, redemption time, you went down 1. So if I go down, what am I doing?
Negative.
To the what?
Down.
To the what, to which
Y,
coordinate?
Y.
To the y, I'm subtracting what?
1.
1. So my rule would be x plus 2, y minus 1. As long as you can count, you're fine. Just remember corresponding points and do not go backwards. Because if you go backwards, you say, well, I'm going to go left 2, up 1. Then your rule would look like this. X minus 2, y plus 1. As you can see, that's the inverse of the actual rule. So be careful. That's really the only way you can mess this up besides not using corresponding points. Let's try 2 quick examples here, and then we'll wrap it up. So I want to go to Katrina. Looking here, just for quick reference, looking at the colors, which one of these is the pre-image, which one is the image?
The black one,
Is the,
the pre-image,
and the blue one is the
image.
image. So we're starting with black, moving to the blue. We can tell that by the prime notation. So what corresponding points do you want to use?
V,
V and? V and what?
and V prime.
V and V prime. If you're choosing V, it has to be V prime. So to get from V to V prime, we always go left to right first. So you have to go left to right.
Left,
Left, how many spots? 1 spot. And then you have to go up or down?
Up.
Up, how many spots? 1 spot. Good job. So we went left 1, up 1. So if we went left, what am I doing to the x coordinate?
subtracting one,
Subtracting 1. And then I went up 1, so what am I doing to the y?
adding one,
Adding 1. Good job. We went left 1, up 1.
You put 0 for right and down.
What happened? We didn't go right or down, did we?
0.
What happened? You don't have to put anything, just leave it there.
Wait, but isn't the blue the prime one? The prime?
The blue is the prime, that's why we started with the black. You start with the pre, you start with the standard coordinate, and you're moving to the prime coordinate. You're moving to the image. So, black is the pre before, and then after we translated it, that's the image. So we're always going to be moving from the standard coordinate to a prime coordinate, never vice versa. Alright, at least not for translations. Last one here, Juan,
Oh yeah.
corresponding points, give them to me, let's go.
X.
ALP, I don't have that. What do you got?
Oh, cause
What do you got, man? Come on. There's not even an X in that one. L. Okay, so L corresponds to what?
L prime.
L prime. So to get from L to L prime, we have to go left to right.
Oh, you gotta go right.
Right? How many spots?
1.
1 and then up or down?
Down.
Down, how many?
3.
3. So real quick, give me the rule.
1, x1,
X plus 1, Y,
comma, y plus 3.
Y minus 3. We're moving down. Y minus 3. Okay?
Listen, I get your 3.